Chapter 7, Developing Early Number Concepts and Number Sense. Research recommends for high-quality learning activities in the first 6 years of life. In 2009, the NCR Committee of Early Childhood Mathematics identified 3 foundational areas in mathematics content for early learners: the number core, the relations core, and the operational core. Roll a die and immediately know that is 5 without counting the dots. The ability to just see it is subadizing. Subadizing is a foundational skill in the development of children's understanding of a number and can be developed and practiced through experience with pattern sets. Encourage students to move beyond counting by ones as soon as possible and instead have them focus on patterns. Only the counting sequence of number words is a rote procedure. The meaning attached to counting is the key conceptual idea of which all other number concepts are developed. This model shows that the new number always includes the numbers before it. Like 4 always includes 3, 2, and 1. 3 includes 2 and 1. 2 includes 1. Show a card with 5 to 9 large dots and ask how many dots are on the card. Ask the child to count the dots. If the count is accurate, ask them to count again. Early on, children may need to count again, but not a child who is beginning to grasp the meaning of counting will not need to recount. Now ask the child, please give me the same number of counters as there are dots on the card. Children need to discover the number 0, particularly as understanding its value is a required standard of kindergarten. Surprisingly, it is not an easy concept that is easily grasped without intentionally building understanding. Kindergartens are expected to write numbers from 0 to 20. Reading and writing numerals is similar to teaching them to read and write letters of the alphabet. Some activities you can use are number necklaces, number tubs, line them up, counting on with counters, real counting on, and counting moose tracks. The concepts of more, less, and same are basic relationships contributing to children's overall understanding of numbers. Classroom activities should help children build on and refine the basic notions. Make sets of more, less, the same. Provide about 8 cards with patterns of sets of 4 to 12 objects, a set of counters, word cards labeled more, less, the same, and paper plates or low boxes that can define the workspace to support children with disabilities. Next to each picture card, have children make 3 collections of counters. A set that is more than the amount in the picture, one that is less than, and one that is the same. Have children who struggle begin by creating a collection of items that match the picture. For children who are ready to use symbols, greater than, less than, or equal, between the quantities, use the relationship card activity page. Another activity, more, less, or the same. This activity is for partners or small group. Make 4 to 5 sets of cards from the more or less cards and 2 sets of number cards. To play, one child draws a number card and places it face up and puts the number on the counters into a cup. Next, another child draws one of the more or less cards and places it next to the number card. For the more cards, the designated number of counters are added to the cup. For less, the counters are removed. And for 0, no change is made. Children then predict how many counters are in the cup. The counters are emptied and counted, and then the game is repeated by drawing new cards. Eventually, the words more and less can be paired with or substituted with add or subtract to connect these ideas with arithmetic operations. Once children acquire cardinality and can meaningfully use their counting skills, they need to expand their collection of ideas about number sense to develop the knowledge needed to meaningful work with operations. We want children to move away from counting by ones to solving simple story problems. You can use the game 1 and 2 more and 1 and 2 less. Benchmark numbers of 5 and 10 because the number 10 plays such a large role in our numeration system, and because two 5's equal 10, it is very useful to develop relationships from numbers 1 to 10 connected to the benchmarks of 5 and 10. Part-whole relationships. To conceptualize a number as being composed of two or more parts is the most important relationship that can be developed about numbers.